All right, so this time we are looking at Unit 6B, the measures of variation. And so to start off, we're going to imagine we have two different banks. In Big Bank, they have three tellers. Each teller has their own individual line. At Best Bank, they have three tellers as well, but they have one teller or one line for all the customers, and they're called to the next available teller. So if we look at it, we have 11 different customers. We're looking at their wait time. Big Bank with three lines has a shortest wait of 4.1 minutes with a largest wait of 11.0 minutes, and then everything's in between. Best Bank has a short time of 6.6, a longer time of 7.8. Now, if you take the average, you'll find that both banks have an average of 7.2 minutes. However, you'll find out that you probably have more unhappy customers with Big Bank than at Best Bank. And if you think about it, when you go to the store and you pick your line, if you notice, there's probably almost always another line that's moving faster than your line, and you will notice it. That's kind of because if you've got, let's say, 5 lines, your chances of picking the fastest line at random are only 20%. There's an 80% chance that one of the line is going to go faster than yours, and that's the one that you notice. And if we look at Big Bank, kind of from last time, this is kind of a uniform distribution. Everything shows up once or twice. With a large or high variation. Best Bank has a small variation with one peak. It's one mode. But because everybody is kind of grouped together, you're going to find a little bit more satisfaction because, well, yes, you've got to wait 6 or 7 minutes. Everybody else is waiting 6 or 7 minutes. With Big Bank, the people that wait 4 and 5 minutes are probably happy, but you're going to notice that somebody's waiting 8, 9, and 11 minutes, and those are going to be the unhappy ones because people are going a lot quicker than they are. All right, so looking at the variation, a couple different things we're going to do. One is the first thing is just we're going to find the range. And the range is very simply the highest value minus the lowest value. It's as simple as that. Okay. If there's no outlier, the range gives you a pretty good indication of what happens. If there is an outlier, then it's going to throw the range off. Much like last time we said that it throws the mean off. Well, an outlier will throw the range off. And if we look at our two graphs, going back up here, notice we have an 11 minutes. That would be an outlier for Big Bank. So the range for Big Bank is going to be thrown off a little bit. Best Bank, everything's close together, no outliers. Okay, so the range is a little more, not accurate, but tells us a little bit more information about what's going on. All right, another way that we can group a lot of data together is to make a 5-number summary. You may remember this from middle school as a box and whisker plot. So in order to do a box and whisker plot or a 5-number summary, you need 5 numbers. So you need the high value, the low value, the median, and the upper and the lower quartile, sometimes known as Q1, Q2, and Q3. So the median is the middle number. So in this case, for Big Bank, 7.2. To find the lower quartile, you take the numbers below the median and find the middle number in that. So in this case, there are 5 numbers below 7.2. The middle number is 5.6, so that becomes our lower quartile. To find the upper quartile, you take the numbers above the median, so there are 5 numbers above, and the middle number for that is 8.5. So those are going to be the 5 numbers that we use. Now for Best Bank, the median is still 7.2. the lower quartile is 6.7, upper quartile is 7.7. Okay, those are the middle numbers. All right, so here's our little chart. So these are the 5 things that you need. The lowest value, the lower quartile, the median, the upper quartile, and the high value. Okay, so we just make a little list. All right, then to make our box and whisker plot. The lower quartile, the median, and the upper quartile make up the boxes. So here for Best Bank, we had lower quartile at 6.7, median at 7.2, upper quartile at 7.7. That made up the box. The low and the high values make up the whiskers. So 6.6, then we drew a little line to 6.7, and then 7.8, drew a little line from 7.7 to 7.8. For Big Bank, the box is made up of the lower quartile, 5.6, the median, 7.2, and the upper quartile, 8.5. They made up our box. And then the whiskers are 4.1 and 11.0. That would be the endpoints. And then you make the whiskers by just drawing a single line. Now, each section contains 25% of the data. So if we're looking at Big Bank, 25% of the wait times were between 4.1 to 5.6. 25% of the wait time was between 5.6, 7.2. 25% between 7.2, 8.5. 25% between 8.5 and 11.0. The smaller the grouping, the more condensed the data, the lower the variation is. So even if we didn't look at either the raw data or the bar chart like we had on the first page, you could look at this and go, oh, Best Bank is a low variation, everything's grouped together, while Big Bank has a higher variation. All right, so we're going to do a little example. And I know it says consider the 2 sets of 20 100-meter running times. Just to give you a little bit, to show how it works a little bit with odds and evens, for the second one, I took out the loss value. Okay, so for set 1, there are 20 times going from 9.92 to 10.38. For the second set, there are 19 times from 9.89 to 11.87. I took out the 12. Okay. 1, just to kind of show you what happens with different numbers. And the second thing is, if you've got somebody running 9.89 and 9.90, you probably shouldn't have somebody running at 12 seconds in that same race. That's just me. I ran track in college, and yeah, they don't go together. Okay, so looking at set 1, there are 20 numbers. We're looking for 5 of them. The lower quartile, the median, the upper quartile, Q1, Q2, Q3, the low value, the high value. So if I'm looking at set 1, the low value is 9.92. The upper value is 10.38. Let's just go straight in. All right, for the median, I'm going to find the middle value. And since it's an even number, just like last time, we're going to have to add up the 2 middle ones and divide by 2. So we had 10.13, 10.14, giving us a median of 10.135. So there's our median value. All right, because the median is 10.135, 10.13 is considered below the median, so that's going to count in, and there are 10 numbers now below the median. So we need to find the value of that median. Okay, so those would be the ones that are underlined in pink. And we're going to have a split again because there's 10 of them. So we got to find the halfway point between 10.06 and 10.07. And that would give us a 10.065. There are 10 values above the median because 10.14 is above the median, so it counts. and we split 10.18 to 10.21, giving us a Q3 value of 10.195. So our low value, 9.92. Lower quartile is 10.065. Median is 10.135. Upper quartile, 10.195. And the high value is 10.38. That could probably be the Olympic trials in the U.S., or may even be Olympic finals or semifinal heat or something like that. Those are really good times. For set 2, low value is 9.89. High value is 11.87. Now, because there's an odd number, 19, we actually have a value for the median, so that would be 10.98. That's our median value. Now, since 1098 is the median value, it does not get included when we're looking for the values below it. So there are 9 values below the median. Okay. And we take the middle value of that. So in this case, 10.35 is Q1. There are 9 values above 10.98. Okay, because that one does not count once again because it actually is the median. And our upper quartile, our Q3, is going to be 11.55. Okay, so for set 2, we have a low value of 9.89, a lower quartile of 10.35, a median of 10.98, an upper quartile of 11.55, and a high value of 11.87. Not sure what race that is. It's a wide range of people to be trying to race each other. All right, so if we are going to make our set, so we have 9 to 12 for our seconds. For set 1, low value is 9.92. Our Q1, Q2, Q3 are put there. Those are going to make up the box. Our high value at 10.38 makes up the whiskers. Okay. For set 2, we have our box made up of 10.35, 10.98, and 11.55. And then the low value at 9.89 makes up one whisker, and then the high value at 11.85 makes up your second, or 11.87 makes up your second whisker. Okay. And once again, we can look at it. Each box and whisker contains 25% of the data. A lot more variation in set 2. Everything in set 1 was fairly condensed, a lot closer together, and a lot more interesting race. Standard deviation. If you have taken a standardized test, which is everybody, one of the things you would notice on there is a standard deviation. Now, the standard deviation tells you how condensed the data is. So if a test has a standard deviation, it means everybody's scores were grouped together. Doesn't necessarily tell you if everyone did poorly or did well. It just tells you whatever the scores were, everybody was grouped together. They either all did really well or they all did poorly. If it's a large deviation, the scores are much more spread out. Okay. So if you took a state EOC, took the SAT, the ACT, and AP test, anything like that that's standardized, you're going to see a standard deviation on there. And once again, the smaller the standard deviation, the more closely the scores were. All right, so to find the standard deviation, the first thing you're going to do is compute the average of the data set. Okay? And then you subtract the data value from the mean, square each deviation, add up the squares, divide by the total number of data minus 1, and then take the square root of that. Okay. So it's, if you will, it's a lot of steps. They're not difficult steps. It's kind of more in the tedious realm than the difficult realm. But tedious, yes. Difficult, not really. Okay, so here is our banks. So for big bank, we had an average or a mean of 7.2. So the deviation, we're going to take 4.1 minus 7.2. Now I know the little instructions above it said to take the deviation of every single one. Well, when you're doing this in the calculator, you're going to square it. So I would recommend just doing each line individually because it's easier to just hit the square button and then get the value. So we got negative 3.1, we square, we get 9.61. Your deviation squares have to be positive. Okay, if your deviation squared value is negative, you have done something wrong. The deviation can be negative, or it can be positive, or it can be 0. But once you square it, it has to be a positive number or you've made a mistake somewhere. So we take 5.2 minus 7.2, we get negative 2. Square it, 4. 5.6 minus 7.2 is negative 1.6 squared, 2.56, so on and so forth. Okay. All right, so then we're going to take the deviation squared and add them up. So 9.61 plus 4 plus 2.56 plus 1 plus 0.25 plus 0 plus 0.25 plus 0.25 plus 1.69 plus 4.41 plus 14.44 gives you the sum. And that gives us 38.46. Now just kind of quickly, kind of along a little bit of a note, if you notice we call it 11 an outlier. Notice the deviation squared is a lot higher than all the other values. Okay, so the higher the deviation, or the higher the further out the outlier, the larger the deviation squared is going to be. Okay, so there were 11 numbers. So we are going to take 38.46. We are going to divide it by 10. Remember, it's 1 less than the number of terms. So in our 100 meter dash one, if we were doing the first one, there was 20 numbers, so we would divide it by 19. In the second one, there was 19 numbers because I took out the last number, and therefore we would divide it by 18. So it's always 1 less than the number of terms, or number of data points. And that gives us, so 38 divided by 0.46, or 38.46 divided by 10 is 3.846. We take the square root of that, and we have a standard deviation of 1.96. All right, Best Bank also had a mean value of 7.2. So we take 6.6 minus 7.2, we get negative 0.6, square it, 0.36. 7.5 minus 7.2, 6.7 minus 7.2 gives us 0.5, squared, 0.25. Okay, so on and so forth. 6.9 minus 7.2, it's negative 0.3, squared is 0.09. Now notice we didn't have an outlier for this one, so all the deviation squareds are about the same value. Okay. So when we add up the deviation squareds, we get 0.36 plus 0.25 plus 0.25 plus 0.09 plus 0.01 all the way down, and we get a sum of 1.98. There was 11 terms, so we divide it again by 10, 1 less than 11, and we get 0.198. Square root of that is 0.44. So if you remember at the beginning, I said Big Bank had a high variation and an outlier, meaning we're going to have a higher standard deviation of 1.96. Best Bank, low variation, low, narrow, high peak. Low variation, so that gave us a smaller standard deviation of 0.44. All right. Sometimes you just kind of are given the range, and you have to approximate a standard deviation. If there is no outlier, you can kind of use a general rule of thumb. That would be the range divided by 4. Okay, so take the high number minus the low value divided by 4. If there's an outlier, technically you can still do it, but your number becomes less accurate. If you know the average and the standard deviation, you can approximate a low score and a high score. So you can do this going back to your standardized tests. A lot of times they will tell you what the average is, and they will tell you what the standard deviation is, and you can figure out approximately what the range of scores were. So to find the low value, you would take the mean minus 2 times the standard deviation, and then take the high value, which is going to be approximately the mean plus 2 times the standard deviation. All right, so we're going to approximate the standard deviations for Big Bank and Best Bank. So Big Bank, we're going to take the high, 11.0, minus the low, 4.1, that gives us 6.9, and divide it by 4, and gives us an approximate deviation of 1.73. Okay, the actual one was 1.96. Best Bank, we're going to take the high, 7.8, minus the low, 6.6, which is 1.2, divided by 4 is 0.3, compared to the actual deviation of 0.44. Notice the one that had the outlier was further off on the approximation. Big Bank had an outlier, so we ended up with 1.73, and it should have been 1.96. Okay, it's a little bit off. Still decent approximation if that's the best we've got. Whereas Best Bank, where everything was grouped together, 0.3 versus 0.44. Okay, so not perfect, but it's a good estimation. It kind of tells you the ballpark of what you should be looking for. All right, if you're just given the mean and the deviation, what about the high and the low? So a Prius gets an average of 45 miles per gallon, has a standard deviation of 4 miles per gallon. What's our estimated high and low gas mileage under ordinary driving circumstances? Okay, so to find the low value, we would take the mean, 45, minus 2 times the standard deviation. 2 times 4 is 8. 45 minus 8 is 37. So we would expect at least 37 miles per gallon under a normal condition. For the high value, we take 45 plus 2 times 4, which is still 8. 45 plus 8 is 53. So our high value would be 53. Okay, so it gives us an approximate low and high value based on the mean and the standard deviation. Once again, if you get a standardized test, you can do the same thing because it should tell you what the average score was and what the deviations were. And then you can use that to figure out kind of what the low and high score are, and then you can figure out from there kind of where you fit in the realm of everybody else. All right, that is everything from Unit 6B.